Hi there! Normally I have several projects going on at the same time, and so the lab is full of breadboards with prototypes mounted on them. Especially when I have to test circuits that require a dual power supply, I tend to use a little device that I built myself and that makes it easy to power the circuits on the breadboard. I have actually two of these devices, and actually I once showed you how to make it. Problem is, I now need a third of these devices because the existing two are already mounted on a couple of other prototypes I'm working on. And so, I need to make another one of them. While at it, I will add to the device a couple of LEDs to show when the power is on, and I will also add a few capacitors to add some filtering before the power enters the breadboard. These parts of the device were not present in the original circuits in the previous video. And so I decided to get two birds with one stone and make a new video to show you how to make one for yourself. Here it is. Enjoy! The circuit I want to make is so simple it is not even worth to draw the schematic on the computer. I will just do it here on a piece of paper and then I will build it right away. It is gonna be basically a cable made of 3 wires. Each wires will go to a different connector that can be plugged into the power supply on the bench, and then basically these wires will go on the board and will go to a bus, one for the positive, one for the negative, and one for the ground. At the other end there will be two more connectors, basically pins that will be plugged into the breadboard itself, like this. And so basically the voltage from the power supply can go directly to the breadboard this way. To visualize that there is actually a power supply applied to the breadboard, I'm going to add a couple of LEDs on the positive and the negative side. So this is going to be the positive, this is going to be the negative, and this is ground, of course. And I will connect the LEDs right over here, like this, with a resistor, of course, to limit the current in them. Another one on this side. Remember to polarize correctly the diodes, otherwise they will not light up. I plan to use a red LED on this side and a yellow LED on this side to distinguish the two voltages, positive and negative. I'm using yellow because in my power supplies the yellow is a negative voltage with respect to the positive, and the ground is black instead. For these two connectors I'm going to use this pin header, and I will cut a little piece of this. I will make sure that I can insert all these 5 holes of the pin header for stability, so they won't move. So I have to cut a piece of 5 plus 5 pins for one side and another one for the other side. Let's do that right now. Basically, when we use the breadboard, I will use the top rail for the positive of the power supply, the bottom rail for the negative of the power supply, and the 2 rails in between for the ground. So I will be able to access ground on both sides, on either side of the breadboard. And this fits precisely over here. Now I have to make another one for the other side. There we go, these are the 2 pieces, I won't need this one. And these are the components that I will be using for the project. A small perf board, which will sit right over here, this way. And then the 2 set of pins that I already cut. And then the 2 LEDs. I found this big ones, 10 millimeters diameter. They're nice, and I don't have any other use for them, so I'm gonna use them. And these are the resistors of 560 ohm. With 560 ohm, I should be able to drive into the LEDs 20 milliamps with plus minus 12 volts. For lower voltages, of course, the current will be less, and the light on the LEDs will be smaller, but they are big, and so we should be able to see it anyway in those cases. This is the cable I will use in between the perf board and the banana plugs, which are here. Black one for ground, a red one for the positive, and a yellow one for the negative. I choose this kind of wires. These are stranded wires, 22 AWG, but the most important thing is that the insulation is made of silicone, so it's very flexible, you can see, and works quite fine, is resistant to heat and so forth. So this will be perfect for my scope. So let's begin. Let's build this thing. Okay, I will begin by putting all the components on the perf board, and once I do that, then I will connect the cables. The easiest way to do that is to avoid putting this on the wrong direction, is to just plug them in on the breadboard, and then let's connect them also over here. There we go. Okay, now that this is in place, you can see it's perfect. Now we can continue add all the other components. I'm gonna put the cables with the banana plugs at the opposite end, so in the center I will put everything else. First of all, I need to connect the pins on the inside here and here together and with each other. At this point, let me grab the cables. Let's start from the side toward the breadboard. But now that I think of, maybe I should do one extra step, and I think I will do it. Let me go back here and show you what I mean. Basically what I want to do is to add a couple of extra components here. In particular over here, a small ceramic capacitor over here, and another one over here, and an electrolytic capacitor a little bigger, here and here. So basically this will help filtering out the noises that the cables may get along the way on the workbench and reach the circuit on the breadboard. This way it will be safer to use this device. I'm going to use 100 nanofarad for this. Let me write it down. So this is going to be 100 nanofarad, this one and this one. And this other one I can put, I don't know, let's see what I have, but I was thinking about 100 microfarads here and here. And remember, these are 560 ohms each. And these are plenty, even a 1/4 watt is enough. And then we have a red LED and a yellow LED. There it is. Let's get to the components and solder them too. Okay, here I have the components, the two electrolytic capacitors and the two ceramic capacitors. I should have thought of this before connecting the cables, but well, better late than never. So I'm gonna put this both between positive and ground and between negative and ground. So let's do that. And then everything is finished. All the capacitors are in place. So now we can test it and see if it works correctly or not. Let's test it now. Okay, so this goes to the power supply. And we should see the LEDs turn on if everything is connected correctly. Otherwise, there will be some smoke. Okay, cables are connected. Let's give it a try. And they burned. I realized that I didn't connect properly the capacitors, and because of that the LEDs ended up being connected directly to a power supply, with the series resistors shorted by the capacitor wires themselves. Rather than spending time replacing the LEDs with a chance of having some other mistake in the circuit, I decided to assemble a new one from scratch, trying to be more careful this time. The one I will test is this new device, not the original one I built. Always be careful when you build your own device on the breadboard. As you witnessed, it is very easy to make a mistake. Always double check everything before soldering the components in place. Okay, so this is the final circuit. Everything is connected. You have the ground over here and over here, then go to the ground on the other side. So the LED are connected to the resistors to ground, and the capacitors here are connected between negative and ground, and this one, these two, between ground and positive. Let's now connect the cable to the power supply. We use a 12 plus 12 volts power supply, and let's see if the system works and the LED turn on. And yes, there it is. This confirms that we have everything in place correctly. The other thing we can do is actually mount this over here and then test the presence of the voltage over here let's do it this way. We'll check it over here and over here and on ground, of course, which is here. So let's pick up the tester and let's take a look. So this is ground. This is supposed to be the positive. And yes, we have 12 volts. And this is supposed to be a negative. And well, yeah, the power supply is not perfect here, so we have -11, but it's still a good one. So it's working. And so you have it. A very simple project for which to spend a couple of hours of work making it. And also a little device that will simplify your life when you need to do work on a breadboard and use a dual power supply. And now I can go back to my other more complex project, for which I will tell you all about it in another video. I'll see you soon, and as usual, happy experiments!